the second video on logarithm properties. In the first video on logarithm properties, we were taking our expression and expanding it into something like this. What we're going to do now is take one of these expressions like this and condense it back into what's called a single logarithm. Here's a quickie review of those three major properties we looked at. The log of a product equals the sum of the logs. The log of the quotient is the difference of the logs. And the log of something to a power is where the power detaches and comes down in front and becomes a coefficient. So I say the exponent becomes a coefficient. So now when we're going to work our way backwards, when you see a coefficient, you have to realize it was an exponent to begin with, and you're going to have to bring it back to be the exponent. This is not a log property, but this is something we will need to use, and that is the fact that the mth root of x to the a can be rewritten in rational exponent form as x to the a over m. You see one of these problems where the word log is written multiple times. The directions are asking you to write it as a single log where the coefficient is 1. You need to write the log, base whatever it is, one time, put parentheses, and then decide what's going on here. This is all addition, which goes back to this first property. If it was addition between here, that means it must have come from being a product. So this is just x, y, a. That is a single logarithm because we've written the word log one time, and the coefficient is 1. With this one, notice we have a coefficient right here that is not 1, and the first thing we want to do is bring that coefficient back and write it as a power. So that's your first step. Secondly, we've got the word log base 4 that we want to write one time, parentheses, and then decide which property we're dealing with. This is log of something minus log of something means it came from a quotient. And the x will go on the top because it comes first in the expression, and the y cubed will go on the bottom. The other reason the y cubed goes on the bottom has to do with what I told you in the previous video, and that is when there's a minus before the word log, that's going to send it to the denominator, just like negative exponents got sent to the denominator. Here we got several coefficients. All of these coefficients need to come back and become the exponents on those variables, which is the step I've got right here. Then it's all log base 3, so we'll write log base 3, parentheses, and then decide what's what. Because there's a plus between here, that's a product. So this is x squared, y to the 4th. But there's a minus in front of this part here, so that z to the 3rd power is going to go to the denominator. It is written as a single log. There is no coefficient other than 1. Similar problem, we're going to bring this 1/4 back. We're going to bring this 3 back, and those are going to be our exponents. Then write log base a one time. This is a minus in between here, so we know it's a division problem, and it will be c to the 1/4 on the top and y cubed on the bottom. The only thing about this is we don't want to leave this as c to the 1/4. We want to write this as the radical form. C to the 1/4 is actually the 4th root of c. The y cubed stays where it was, and it is still all log base a of that. You can have something in parentheses and it's still the same idea. Notice there is no base written. Remember, that just is talking about the common log. We don't have to write a base. We're just going to write the word log here one time. Draw your parentheses in there. It's a minus in between those two log words, so it's a division problem. And what goes in the top is x plus 3, and what goes in the bottom is 2x minus 1. Now, I could continue with those being in parentheses. I just don't need to. Next problem, bring those coefficients back to become powers, and that's what you're looking at right here. Then we're going to write log base a one time, parentheses. This d to the 1/2, that's a positive. It's going up to the top. This has got a minus in front. That's going to send this down to the denominator. This is back to plus log base a of n, which means it's going to stay in the top. And then the only thing we need to work on is this d to the 1/2, which is the square root of d, and x cubed in the bottom, all of this log base a. These properties Hold for ln also. That coefficient still needs to come back and become a power, so that this next step looks like this. Instead of having to write the word log, we're going to write ln. There's a minus in between, so it's division. And the x minus 6 goes in the top, and the x squared goes in the bottom. All of these that we have done, we have written this as a single log. And the whole purpose in doing this, you'll see in the next video when we talk about solving logarithm equations. To solve logarithm equations, they need to be written as single logs before you can solve. That's why this condensing strategy is important. Similar problem, bring all these coefficients back, which is going to give us this step. And then we'll write ln one time. We'll use parentheses and then decide what's going on here. This is a plus in between here, so this x squared y cubed is being multiplied. But we've got a minus here, so this is z to the 1/2 on the bottom, but just to save time, knowing it's z to the 1/2, that's the same as the square root of z, and that's that one. Part of this video is about what's called the change of base formula. It turns out to be a very powerful formula, and it's very simple to use, and it's very simple to memorize. It says, for any logarithmic bases a and b, and any positive number m, log base b of m equals log base a of m over log base a of b. M goes to the top, and the base goes to the bottom. The base goes to the basement. This log base a, you get to pick whatever base you want. It makes sense for us to pick the common log because then we can use the calculator. Now, I can't explain to you where this came from yet, but in the next video when we start doing logarithm equations, I can tell you why. So for right now, just memorize it and be able to use it. This is why this is so helpful. If I asked you to do log base 2 of 8, you can do that in your head because you know 2 to the third gives you 8. Therefore, log base 2 of 8 is 3. That's simple because you know what power goes on 2 to make 8. Well, do you know what power goes on 16 so that it equals 7? No, me either. But this property tells me that all I have to do is use this and I can use my calculator. It will become log of 7 over log of 16. So that's the same problem right here. Log base 16 of 7, according to the property, becomes log of 7. That's the log of the number goes to the top over the log of the base. Remember, you could use whatever base you want, but it makes sense to be the common log so that you can use your calculator. So we use the calculator, we do log of 7 and we get this number, log of 16 we get this. We always go out to 4 decimal places and then type it in, divide it out, and that's your value, 0.7019. Can we check this? Yes. We're saying log base 16 of 7 equals this number. In other words, 16 to the 0.7019 better equal 7. And you can stop the video and type that in your calculator and see that that works. 2 comments about these values. One is these are not exact values. If you type log 7 into your calculator, it doesn't just stop with the 4 digits. We have just always used 4 digits, so these are rounded off to 4 digits. The other comment is that if you want to go directly into your calculator with this information and not write this down, that's fine, but you have to be careful. On the TI-83 and 84, when you press log, you automatically get a front parenthesis. So you would type the 7 in. You must close off that parenthesis before you hit the division sign. And then log, you get your front parenthesis of 16. Because that's the last thing you do, you don't necessarily have to close off that parenthesis there. So use that if you want. I'm going to continue on this video to go ahead and show you these values here. But I wanted you to be aware of that these are not exact values. They are rounded off. Log base 5 of 19, same setup we used a second ago. This is going to become the log of 19. That's the log of the number goes to the top. The 5, which is the base, goes to the basement. And then here are the values. Round it off. Divide that out, and there's your answer. But you can go directly log, get your front parenthesis, 19, close that off, divided by log 5, and you will get the same answer. You just won't have these values to come up in the middle. You'll just get a final answer. This looks kind of weird to have a base of pi, but it still works the same way. It will be log of 9 over log of pi. Type in, and you get these. You do have a pi button on your calculator, so you can hit log pi. If for some reason your calculator does not have a pi button, well then you could just use the approximation for pi of 3.14 and then divide it out, and that's your answer. So that is your change of base formula. It is very helpful when you have to evaluate log base something that's not base 10.